Welcome to Phylogeny.io, an interactive, web-based tool for visualizing phylogenies in your browser using the D3 JavaScript library. Before I introduce the tool itself, I'm going to spend a couple of minutes talking about the problems it intended to overcome, using a concrete example. Corey Moreau and Charles Bell published the phylogeny of the ants and used it to test a number of biogeographic hypotheses in the journal Evolution, one of the top journals in the field. This is an excellent study, but the traditional publication format on paper makes it harder to read than you would like. For example, the major outcome of this study is in fact the ant phylogeny. But printing it on a piece of paper is quite difficult. And in fact, Evolution split it across 3 separate pages. So in order to see all of it, you have to flip from one page to another. Or maybe perhaps you print it out and paste it all together. Furthermore, this tree has a lot of species and you probably don't know anything about them. So if you want to learn something specific about, say, what Martialis heureka is, you have to maybe copy its name and look it up elsewhere. But the tree itself won't tell you. Furthermore, the actual tree topology is only one of the findings of this study and is duplicated 2 other times in the paper itself. For example, in addition to this large tree, there is another tree that is exactly with the same topology, but now squished into one page, and also it provides confidence intervals for the various nodes. You have to really zoom in order to see what the species are, and then hope that as you scroll down, you'll actually be able to find what node they match up to. And then there's yet another version of this phylogeny, now with biogeographic data projected onto the nodes. And ideally, you might want to have all 3 sources of information in order to make a conclusion. But you really cannot do that in this one figure. And as a result, an excellent study becomes much more challenging to read than it should be. And Phylogeny.io exists to solve this problem. We'll start by loading the example tree, which happens to be the Moreau and Bell tree from the paper. You can see it's loaded successfully, and we can close this window to get more real estate. And now we have the tree in front of us. We have the same problem as the original paper in that the tree is really too large to fit onto our screen, even if our screen is very large. We can play around with the different kinds of projections by making the tree flatter or narrower, but inherently it's still pretty difficult. But as you can see, we can zoom around and make the tree shaped to our liking. We can also change the projections, particularly making it a circular phylogram, which could allow it perhaps more species to be squeezed on. And we can rotate it as the helpful hint suggests. Now, the key benefit of D3 is we can call up a lot of information that is stored in this tree. For example, we can hover over every node, and then we have all the stats that we may want displayed. So here we have all the outputs of the phylogeny generating program. But what it is really depends on the input file. We can also click on individual nodes and species, and voila, we have additional information, such as an image called up from AntWeb, and other kinds of information. We can even click on some of these and go to other websites that will give us more information yet. And of course, we can zoom in and scroll around and close these different panels. Now we'll take a look at the side panel. It has very many features and looks a little bit intimidating as a result. But with a bit of experimentation, you will find it to be extremely powerful. In the upper left-hand side, you have a space where you can import files. Currently, Newick files are supported. Nexus files have a lot of different options, so not all of them are supported directly. You may need to edit some of them. And there is a custom JSON file generated by Phylogeny.io, which you can export and import to save all the settings. When you click on Entry, it's equivalent to dragging a file to that window. So this is our example file. You already saw the layouts, and they're reasonably self-explanatory. So let's take a look at the Miscellaneous tab. And in particular, there's an option to rotate the tree by ascending or descending order. You can rotate individual nodes in real time, and you can select either individual branches, like this one, individual taxa, like this one, or whole clades, like this clade right here. Now, using this selection, you can actually color code them manually should you so desire. So for example, we just colored this whole clade red, and now this taxon is selected, so we can add additional annotations, including hyperlinks, etc. And you can see they're immediately reflected in this tree. Now, there are other ways we can illustrate our tree. You can change node labels, you can change node shapes, you can also change branch labels, and of course node bars. So for example, node shapes, currently they're circles, but you can change them to rectangles, or you can change to diamonds. And you can size them by any kind of annotation available in the tree. So here we'll choose the rate median because it's the most dramatic contrast, and you can change the relative size as well, and also color code them by whatever value you might like. If you want to play with other aspects of the display, you can go to the Branch Projection tab, which offers a couple of other views. So in addition to the elbow view, there's the diagonal tree that gives you more curved branches. And there's also direct lines. You may need to sort the tree a little bit and rotate some of the nodes if some of the lines overlap. So these two require a little bit more hand-holding. And last but not least, there is a scale bar which you can show and hide and alter in various ways. Finally, there are also links to the home page, the changelog, and the About button, which has the help material. I'm going to briefly introduce how to share a tree, making it possible for others to view it. There are a few ways to export this tree. You can export it as a vector format, as an SVG file, which you can then edit in some sort of external software, for example, for publication. And you can see it generates a file in your computer. You can also export it as a PNG file, as a bitmap format, and as a JSON file, which allows you to re-import into Phylogeny.io later. But most importantly, you can click the Share Chart link to generate an image. So you can enter the title, optional description, and a frame width and height if you want to put it into an iframe object. And you can select how long you might want it to stick around. So when you generate the link, you are given an iframe code that you can paste into any website, and even a link that allows you to go back and edit this tree later in case you want to modify it or come back and edit it again. So to see how this actually works in practice, you can go to the help site, and at the bottom you actually have the ant tree that's embedded as HTML with all the features and annotations that are served through Phylogeny.io. So you can do this with any tree and add it to literally any website. So this allows you to take any phylogeny and make it shareable with others. I really hope you find this site useful. There is a contact us link above the website in case you report any bugs, which are still likely to be found, or if you have suggestions for improvements. This project is open source, and you can find a GitHub repository with the code in case you want to tinker with it or expand it further.